This video will address several non-destructive tests that are common in the foundry industry for testing cast components. To begin, I'd like to give you some background on the topic. Cast manufacturing is used for automotive parts, heavy equipment, and other structural components with complex geometry. Common materials include aluminum, iron, and steel, but other metals may be used as well. Cast components are manufactured by pouring molten hot metal into a sand mold. The molten metal is then cooled and solidified, forming the part. As a result of the manufacturing processes, castings generally end up with rough surface conditions, grainy crystal boundaries, and have the potential for internal defects. Due to these characteristics, there are a number of non-destructive testing techniques that apply to cast components. These include eddy current tests for surface cracks, an ultrasonic test for thickness, porosity and voids, and graphite nodularity. This first example will cover porosity and void detection using the EPIC 650 flaw detector. It's common for internal porosity and voids to occur in more central locations within a cast part. This is where it takes longest for the metal to cool with respect to the outer edges. Because of the rough outer surface and scattering effects of castings, we will use a low-frequency dual transducer, such as the CHC 706-RM, for the inspection. This will be paired with a dual cable to connect to the EPIC 650. High pulsing power can be used to increase sound penetration into the sample. We can detect our production flaws by looking for echoes occurring before the backwall echo on our live A-scan display. Larger flaws will generate larger amplitude echoes. In some cases, flaw sizing techniques such as DAC or DGS are used in combination with software options like backwall echo attenuator in order to develop an acceptance-rejection criteria. Graphite nodularity testing in cast iron can be done with any instrument that is capable of measuring sound velocity. This includes an Olympus ultrasonic flaw detector, ultrasonic thickness gauge, or a pulsar receiver system. The practice of adding graphite to cast iron is commonly used to enhance the material's mechanical properties. Gray iron is formed when added graphite arranges itself in the form of thin flakes. This results in a more hard and brittle iron. The more desired graphite microstructure is in the form of spherical nodules, which produces a more soft and malleable iron. This material is known as nodular iron. We can check nodularity by measuring the ultrasonic sound velocity through the material. Each material will have a different sound velocity. In order to measure it correctly, it is important to know the true thickness of the sample you are working with. To perform the test, we will use a heavily damped single-element transducer for penetration and accuracy. If needed, we can use high pulsing power to ensure sufficient penetration. Once a clean backwall is visible, we can calculate the material velocity based on our known thickness and make sure that the sound velocity is appropriate. This gives us confirmation that the microstructure is uniform and that the graphite inclusions are of the right form. These are just some of the foundry production processes that Olympus products can enhance. For more details and information, contact your local representative or visit us online at www.olympus-ims.com.